Hello and welcome to How to Improve Data Access and Simplify Disaster Recovery. Uh, my name is Henry Axrod, and I'm a partner solution architect for Amazon Web Services, and I'll be hosting and moderating today's webinar. Uh, in addition to myself, I have with me today Jens, who is a uh, manager of cloud solutions architecture at NetApp, as well as Mike, who's the Vice President for Brightspace Cloud and IT at D2L, and Stan, who's the Director of AWS Enablement at D2L. Just briefly on today's agenda, we're going to again hear from our speakers, myself from AWS, the speakers from NetApp and D2L. I'm going to start off with a overview of disaster recovery at AWS. Then we're going to look at from NetApp a customer expectations when moving to the cloud, and at D2L we're going to learn about how they reduce risk while migrating critical data. And then, as I mentioned, we're going to have a QA at the end. We have a few learning objectives from today's webinar that you'll see, and some of these are we want to ensure that learn how to ensure your data is backed up and recoverable for disaster. We're going to understand how to establish cost-effective secondary copy of data that provides adequate protection. We're going to learn about managing automatic failover and quick, efficient failback process. We're going to learn about easily managing and testing your DR environment, as well as maintaining long-term data copies to comply with regulations, which is increasingly becoming important in the industry. On that, we're going to jump right in and learn a little bit more about disaster recovery and AWS. So there's a few things when we look at disaster recovery with AWS. So one is understanding where disaster recovery comes into play. So disaster recovery is evolution. First, you start with high availability, which is essentially local protection and running of services that keep your applications running in a running continuously. So if you have a localized failure, perhaps you have clustering or other things that keep that application available to the customers. Then you go to backup, which is essentially a protection for the data. So high availability protects the application's availability, backup protects the data's availability. And then you go to disaster recovery, which essentially will allow you to recover your applications and bring your business back to a working state in the case that your primary site or your primary location where you're running your application is no longer available due to some type of disaster. So a couple of the key concepts when we talk about disaster recovery is what we call recovery point and recovery time objectives, or RPO and RTO specifically. And when we look at it from a time perspective, essentially the recovery point is when you want that data from. So it's the furthest point that you want to be able to that you're willing to um, lose access to a specific set of data. So, from that recovery point to the disaster is where data loss can happen. So it's important to determine the recovery point that meets your business needs. Some customers do things down to days or hours or minutes, or even close to zero time recovery point. Um, And then on the other side of it is the recovery time objective, and essentially what this is it determines how long that or how quickly you need to recover once a disaster does happen. And again, that could be anywhere from minutes, hours to days, depending on the needs of your business, and it's a balance between cost and time. So we have four main architectures that we look at from a AWS perspective when it comes to disaster recovery, and they go all the way, up and down the spectrum. Again, as I mentioned, balancing RTO, RPO, as well as cost, and using various services that are available with AWS. So they go all the way from just utilizing backup and restore for disaster recovery, a pilot light scenario, which you have a small set of services, available that you can expand during a disaster, to warm standby, where you can have your base services, available to be spun up quickly in a AWS environment, to the quickest recovery method, which is a full hot standby, where your application is actually fully running in multiple sites or multiple AWS regions. And speaking of AWS regions, I wanted to quickly show everyone what we describe as regions at AWS. So AWS has 18 regions around the world, uh, and that's ever expanding. We have four new regions that are planned by early 2019. Uh, and these regions are geographical locations where we cluster data centers. Those clusters of data centers we call availability zones. So we have 55 availability zones, around the world, contained within those regions. So an availability zone is, one or more data centers uh, that are logically connected. We also have, many points of presence around the world, which are part of our edge network. So a key component of disaster recovery on AWS is Amazon Elastic Cloud Compute, or EC2. And EC2 are the virtual servers that are on the AWS cloud, and they allow you to quickly scale up and scale down as you're needed, which is a key component to disaster recovery, and some of the methodologies that we talked about, such as pilot light and warm standby. They also are utility-based pricing, so you're only paying for what you use. So when those instances aren't running, you're not paying for them, and you only pay when they get spun up. Uh, in addition, we offer a wide variety of different instance types that help service whatever needs you may have. Anything from our general purpose instances, to instances that are optimized for different workloads, even to our latest EC2 bare metal instances that allow you to get even closer to the hardware. We also offer a wide variety of storage services to meet your needs. Everything from our Amazon Simple Storage Service, or Amazon S3 as it's commonly known, which provides a highly durable and scalable object storage platform with virtually unlimited capacity. We also typically, in disaster recovery cases, as I mentioned, since we're using Amazon EC2, we typically see block storage, which is Amazon Elastic Block Storage or Amazon EC2 Instant Store, utilized to as part of that disaster recovery plan. Uh, in addition, some customers, depending on their needs, may utilize AWS Direct Connect, which gives you a connection directly from your data center or co-location facility to an AWS region with dedicated 1 or 10 gig bandwidth. We also offer several other services, as you can see here. At AWS, security, we say, is our job zero. We take security very seriously, and we have developed many security best practices over years of managing the cloud. We have something that is called the AWS Shared Responsibility Model. And as part of the AWS shared responsibility model, AWS is responsible for the security of the cloud, and we say the customer is responsible for the security in the cloud. So, what does this essentially mean? Uh, Essentially, AWS is responsible for the hypervisor and physical layer security down to the facilities where we run the physical facilities and security of those facilities and regions and availability zones that I mentioned before, where we run the overall global infrastructure of AWS. The client is responsible for building secure applications on the AWS platform, which includes, owning and managing their data. AWS, as well as our Amazon Partner Network, or APN partners, provide a large set of tools and best practices that allow you to encrypt your data, protect your data in various ways. So the customer has those available to them to help protect their data and applications. Uh, Finally, AWS has a wide range of industry and internationally recognized certifications and assurance programs that we work with. Anything from SOC 1, SOC 2, SOC 3 to ISO 2701 or 2717 and 18 for cloud privacy and security. Customers could be PCI and HIPAA compliant on the AWS cloud platform, as well as several public sector certifications such as ITAR and FedRAMP, anywhere from low, moderate to even high in some of our public sector locations. For additional information on security certifications, you could see on the AWS website. And also under NDA can be provided with some of the certification reports. On that, I'm going to hand it to Jens, who's going to tell you a little bit more about the Cloud Volumes ONTAP solution on AWS.
Oh, good morning, everyone. Good afternoon, good evening, wherever you are. My name is Jens Dickmeis. I'm Manager of Cloud Solutions Architecture at NetApp. And what we're going to talk about is a service that we offer with inside AWS called Cloud Volumes ONTAP. The question I get asked a lot is, what is it? Can we advance the slide, please? Thank you. So Cloud Volumes ONTAP, NetApp is traditionally known for doing physical hardware systems, and we built an operating system to run on these that's very robust. What Cloud Volumes ONTAP is a virtualization of that same operating system that we use in the on-premises enterprise class storage environments, and we ported that to AWS to be able to go and run those same kinds of storage efficiencies and the manageability that you get from an on-premises NetApp environment. So what you get with that is the NetApp snapshot. Storage efficiencies, which are deduplication, compression, and compaction, are all in play, helping reduce the footprint of your data that you put into the cloud. And then we apply for all kinds of other features like your multi-protocol access, so you can do NFS and SMB off of the same source, which is a huge selling feature. You can do shared block storage to your VMs out in the cloud using it. So very, very nice feature set for that. And for anyone that's already a NetApp customer and is used to using the manageability tools that are in play for their on-premises environment, their system manager, their Unified Manager, the on-command insight, all of that is still in play for Cloud Volumes ONTAP. But there's one more management piece that we built, which actually helps you simplify a lot of the tasks that you would normally do on an on-premise environment, and that's called Cloud Manager. And that's what's needed to go and deploy and configure the Cloud Volumes ONTAP systems, but it can also be used to go and manage your on-premises and simplify a lot of those tasks that a dedicated storage admin has been doing and are very time consuming. Cloud Manager is a nice graphical user interface as well as an API engine that can be used to go and manage the environment for you. So if you're doing any automation, you can do API calls against the Cloud Manager to go and create volumes, create shares, a lot of the functionality that you have, manage your replications. Do all of this here either through the API or simple drag and drop and configuration options for it. So question a lot of customers, why would I not use standard AWS resources and instead of using Cloud Volumes ONTAP? Well, a couple of standard things that we say is that you're up and running in minutes. Well, that's not really a differentiator, but you get the enterprise class storage capabilities out in the cloud that you may be used to on premises. You get those great storage efficiencies, which help reduce your costs out in the cloud, because that's really one of the big things that we see out there. But you're able to go and actually make more efficient use of the resources that you have in the cloud. Like I mentioned, you have multi-protocol, you have iSCSI, so for your block storage, and really helping you go and manage your data out in the cloud easier. Migration using SnapMirror and SnapVault technologies from your on-prem to the cloud. This allows you to go and take your on-premises workloads that traditionally were difficult to go and use out in the cloud and port them without modifying and having to rewrite your application or your process flow, and just get all of that up in the cloud quickly and easily. We're going to talk about architecture, use cases first, and then architecture. So we see 4 general use cases out in the cloud. Disaster recovery being the primary one that most people start to go to the cloud, because you're able to go and get rid of a data center and start reaping those cost savings of not having to pay for that physical location, the physical hardware that's there, and being able to go and get your disaster recovery out in the cloud. And like I said before, this is a simple drag and drop operation to get your data from on-premises to the cloud, and then have the SnapMirror technologies that we have created get that out there for you. With our data tiering capabilities, where we go into tier data to an S3 object storage, we're able to get your DR costs down to as little as 3.5 cents per gig per month. Again, that's going to go and vary depending on the amount of data that you put out there and the kind of efficiency savings that you get through deduplication compression. But we've seen the numbers that low to go and get that out there. So that's a very cost-effective DR solution for you. The next one that we see is that a lot of customers will run their production workloads out in the cloud. This is that customer that says, I don't want to be in the data center business anymore, but I want to have the same kind of manageability that we have. So you still have to go and think of your disaster recovery when you're out in the cloud, because what happens if a region goes dark? What happens if an availability zone goes dark? You need to be able to go and think on, how am I going to build this for failure, rather than having to go say, hey, let's go and see what's going on. And then we're going to go and create a high availability solution in one region and then replicate that to another region, so that you not only have in that one region a 0 RPO and under 60-second RTO scenario in the event of a failure of one availability zone or an item in an availability zone, but you also have that disaster recovery that gives you that I need to go and make sure that if that entire region goes away, we can go and get you out and running properly in another region very quickly, keeping your environment operational, because downtime equals profit loss. The next one that we see is that we have a lot of customers doing DevOps. And honestly, this is, in my opinion, a really killer application for Cloud Volumes ONTAP. If you're running DevOps traditionally in the cloud, you're having to go and have your data set, do a backup, do a restore, and that can be very time consuming and cost consuming. So doing it with Cloud Volumes ONTAP, you can take your on-premises data set and mirror it out to the cloud quickly and easily. And then you can create zero cost, near instantaneous clones of your application data to do your DevOps against, and it's fully read-write available. And like I said, it's instantaneously available. And uses no additional space, which is really nice because we've had customers that were doing traditional DevOps, and it was taking them upwards of 20 hours to get a full working set available to them. We had them switch to Cloud Volumes ONTAP, and this data set replication that they were having to do went from 20 hours to under a minute to have 5 to 6 to 10 copies of that same data set. And they were able to go and get their DevOps teams to become much more productive. The last one is file services, and we actually see this quite a bit where people want to have shared file services out in the cloud. Being able to go and do a NFS and an SMB off of the same source is a massive advantage that NetApp has, so that you can go and get your users to go and put your data in using a standard Windows client, and then have your analytics run on it against the NFS export, and then being able to go and just have a single data source rather than having to go and say, okay, my users are going to go and put the data into an SMB share, then I have to copy that data into an NFS share, and then have to pay for that twice, and then bring the data back from there for the end users to analyze. And so there's a lot of work available in there. One of the big things that we've seen, we all heard about WannaCry. One of the great things with our snapshot technology is that we're able to actually go and restore data very, very quickly in the event of an encryption event that happens. And if you need more information on that, you can reach out to us at NetApp. That's a very, very good use case for it. All right, so we've talked about some of the use cases. So we're going to go and talk about architecture aspects of this. And next slide, please. Perfect. So Cloud Volumes ONTAP architecture is we use the resources that are available to us in the cloud. So let's start off at the 50,000 foot level. So we take a VM, an EC2 instance, we attach AWS disks into it, we create an aggregation of those disks that'll give higher levels of performance for you, and then we go and create volumes off that and volumes and LUNs to go and be consumed by the end user. So that's really high level. So let's dig into that a little bit. So of the disks that we support with Cloud Volumes ONTAP, we support the general purpose GP2 disks, the IO1 PIOPS disks, ST1, which is throughput optimized spinning disk, and then the cold HDDs. Each one has a different characteristic, and depending on the workload that you're trying to go and use, you will determine which kind of disks that you want to use for that. And it's very important to go and architect that around your disks as well as your EC2 instance when you deploy this. So then we take those disks and then we attach those disks to a virtual machine inside your VPC, or virtual private cloud, and that VPC is inside an availability zone inside the region. So it gives you a good understanding of that. There will be a VPC endpoint that you need in your environment to enable tiering, and that is an S3 endpoint, and then an S3 bucket can get attached to that and then give you much reduced cost by pushing your data that is no longer active into that S3 bucket. So that is a single node. But if you want to go and architect for failure, you want to go into a high availability solution. If you're going into a high availability solution, you want to go and deploy two nodes, which we call an HA configuration, and it's deployed automatically for you through our cloud manager. It deploys a node, an EC2 instance in 2 availability zones, and then it attaches disks. And it does a synchronous mirror between the 2 nodes. And that synchronous mirror happens as a write comes in, it gets written to the disk on node 1, immediately gets written to the disks on node 2, and then an acknowledgement goes out. This configuration allows you to have a 0 RPO and an under 60-second RTO for your environment on your primary data set. So that gives you a really high resilience solution. In the event of a failover, because the data is already mirrored over between node 1 and node 2, all that happens is a DNS entry change happens, and then the connections go from the primary node to the secondary node, and the data is being served out to your customers or the application that is still attaching to that with 0 downtime. So really, really important. When the node does come back, what ends up happening is that the data gets synced back over and puts node 1 back into a known good state, switches the node back to node A as primary, and everything is up and running. As you can see, there's a third node that's in play for this called a mediator node. This mediator node allows the systems to go and be monitored. It does heartbeat between the two of them. It also does a veto vote, because anytime you have a two-node cluster, you can run into an issue of split brain configuration, and it avoids that. The other job this mediator node is updating the route table to make sure that it's pointing to the right node in the event of whichever node is offline. We have a third option for this here, and that's in high availability with inside a single availability zone. The benefits of this is that it's actually a little faster to transfer the data. The downsides are you are going to be in a single availability zone, so you've added a single point of failure potentially into your environment. And that there's benefits to doing either or. If you want more information on that, please come and see us at cloud.netapp.com, and we have a great chat functionality there. So the next part we're going to talk about too is data tiering. Oh, sorry. So we're going to talk about our snapshotting and how our basic operating system. So we're going to go a little bit deeper down. So when we write our disks, we actually have our own file system called Write Anywhere File Layout, or WAFL. And that WAFL technology, basically you write data in and it gets written into a block. When we take a snapshot, that snapshot locks those blocks, and then it goes and allocates those blocks to be available for other uses like flex clones. When we create a flex clone, all it does is it points to the active blocks, does not overwrite those because those blocks are now in a locked configuration and are not overwritable. And then it makes it available to go and clone off of it. You can keep writing to your data into it, and it goes and writes at the end of the block chains that you have there, and then makes it available to go and keep writing. Your flex clone writes its own independent blocks, and this is all done at a 4K block level. So what this means is that if you're doing a snapshot of node 1, and then you create a flex clone of that, and you keep writing to it, instead of having a whole bunch of incremental storage for each incremental write that you do or every clone that you do, instead of having to go and have 6, 12, 14 additional blocks, you only have 2 blocks for an extra block write in each of the primary data set and the flex clone. All right, so backup and recovery. When we're doing backup and recovery, there's 2 options available. So backup is when you're doing like your disaster recovery, your snap mirror between one site, and we call that a NetApp snap mirror. And that does a synchronous or an async replication. Once the initial baseline is done, it only has to go and copy changed blocks at that time. So it's only a delta copy. So it's very, very efficient to go and move your data over that. And as the mirror would indicate, what you have on the primary source is what you have on the secondary source. And this can be configured to as little as 5 minutes for a replication schedule. The second option is to do a snap vault, and a snap vault is for your longer term retention. So say I need a 7-year replication or backup policy on that. I want to go and make sure that data is available and not and offline. So you go and snap vault from the source to the destination and say this particular snapshot is going to be locked for the next 7 years. And that gives you that longer term retention to go and help you meet your compliance requirements out in the cloud. All right, so data tiering. This is a new feature that NetApp has created to go and help you reduce your costs of primary storage. The concept is that there will be a performance tier and a capacity tier. And when we go and create a capacity tier, you can go and use your S3 bucket for that, and then you can use either S3, S3IA, or S3 single zone, and depending on what your requirements are and what your cost models that you want to have for that. We have 3 policies that are available for that. The First one is a backup policy, and that one there is the one that you use to when you go and do a DR. So when you snap mirror from the source to the destination, the data will immediately get pushed into an S3 bucket and have it available in the event of a DR. You break it, the data gets automatically hydrated back as it gets accessed onto the performance tier. And then when you go and re-enable the mirror relationship, it'll push that data immediately back down to the S3 bucket, really dropping your cost of having a DR solution and making it quickly available. The second policy is where we do snapshots. Like I've mentioned, we have these snapshots that we create, but those quite often those become old data that's no longer part of the active file system. Should that live on your performance tier? Probably not. So we move that data off of the performance tier into the object storage. The third one, which we released recently in 9.4, is where you can actually tier your live data set. And you go and set up a policy in your environment that says, if my data hasn't been touched in X number of days, by default it's 31, but configurable between 2 and 63 days. Once it's aged off, it will actually move that data into the object store, reducing your spend on the performance EBS disk. So graphically, the two of them look basically that you don't need to have a large EBS footprint to go and have a DR solution for the first one. And traditionally, when you were doing DR, if you had 100 terabytes of EBS on node 1, you would need 100 terabytes of EBS on node 2. But in the backup scenario, if you have 100 terabytes of EBS, you will only need to have 10 terabytes of EBS by default, and that's configurable. And then the remainder of all of that data will go down into the object storage, really dropping the cost of your disaster recovery scenario. The second policy, like I said, it just pushes the snapshot into the S3 bucket. And that basically frees up your performance tier for your applications, be able to have all of the capacity that it needs without being impacted by any of the snapshot copies being held there. The live data tiering, most customers, we find that after 30 days, 70% of their data is never accessed again. Why would you want to go and keep that on your expensive performance tier? Push that down into the object store, really reducing the footprint of your data on EBS. But what happens if that data gets accessed again? Automatically gets pulled off of the object store, stays in the EBS until it expires again, and then gets pushed back down. Complete automatic management for you. To go and enable data tiering, like I mentioned before, you need to go and have a VPC endpoint in your environment to S3. And then there is an S3 bucket that gets created as part of the deployment of your Cloud Volumes ONTAP, and that it will have a name of Fabric Pool / Cluster UUID. And there's only one bucket needed for an HA environment. So again, this helps reduce your storage footprint for HA because that bucket can be shared. Whereas EBS disks cannot be shared between two nodes. And now I'll pass the mic over to Mike.
All right, thank you. Hopefully everybody can hear me all right. Pleasure to talk to you all today. I thought maybe I'd start quickly by introducing our company. So D2L's Desire to Learn. For those of you who aren't familiar with us, we're a SaaS platform for delivering learning management systems. And our mandate is to transform the way the world learns. And so we've been trying to do that for almost 20 years across higher ed, K-12, and corporate segments. My role within that company is to ensure that the SaaS platform is up, running, and responsive around the clock, and also to move it all into AWS. So we want to talk a little bit about today. So requirements, business requirements for this journey. So we needed to move petabytes of data out of our global data centers and had to do it in negotiated windows. So NetApp Cloud Volumes ONTAP gave us the protection, the visibility, and control we needed to do that. We needed to be highly available. Availability is a strong and a major theme for me. You'll see a quote later on where I managed to get the word available in 3 times in 2 sentences. So, but it's an expression, I hear it used in sports. The best ability is availability. If you aren't there when you're needed, somebody's going to take your spot. So we had to make sure that uh, we maintained that throughout. Disaster recovery, our current process is very manual, and in the event of a true disaster in our colo facilities, we were concerned around RTO times in particular. So as part of the migration, we were looking to ensure that we made that a non-issue. Scalability, so because we're providing a learning platform to students, it's very critical at certain times of the year that that we're able to grow and expand and not have to provision for peak as we did in the past. As you can imagine, most of our customers are higher ed, and when at the start of these semesters we get a huge influx of data, and so we have to scale up then, and then as things settle down throughout the semester, they contract, and then we get closer to exam times, they expand again, and then they contract, then we do it all over again when the next semesters roll around. So that, we're a perfect use case for an elastic type of environment. And then we're one of those customers who wants to get out of managing the physical data center environment completely. We want to free up our skilled people to innovate, spend more time on our product roadmap and release frequency efficiency, and less time on the hardware stuff. So decision was go all in on AWS, and as part of doing that, improve the base capability of the DR solution. So having ONTAP in the cloud helped us ensure that we're not only meeting our contractual obligations around RTO, RPO, but we're now actually exceeding them. So it's been a fantastic solution. That manual effort required a lot of time on our staff, so we've been able to reduce that substantially as well. But the first steps were to get the migration done, and then start, ensuring we were stable in the AWS and ONTAP cloud environment, and then start bringing the DR pieces over as well. So, so underpinning the solution, you can see we're using EC2, S3, and because NetApp is an AWS Advanced Technology partner, it made it easier for us to leverage the marketplace as well to do that. So why NetApp and AWS? Well, when I took this role back about 2014, the company had 5 storage platforms. Each time we would try to introduce and run our workloads on a storage platform, it would fail. And not only that, we wouldn't end of life the old platform, we'd introduce a new one. So what I came into was really 5 completely disparate storage platforms. So we made the decision to consolidate onto NetApp after careful analysis. This is still within our colos, and that was incredibly successful. So we stabilized that environment, and it was great. But then the decision came down that we were going to move into public cloud completely, and because we already had success with NetApp and the Cloud Volumes ONTAP product was available to us in AWS, we said this gives us the confidence now to take some of the risk out of moving to a completely new environment by using technology and a partner that we were already comfortable with. So so that's been very successful. On the DR side, we're using snap mirrors, snapshots. This is essential to ensure we're meeting our backup and our DR commitments. We talked a lot about the differences between those already. Compliance, we use SnapMirror. As you can imagine, with all that student data, there's a lot of obligations and a lot of concern that we manage and maintain that data and curate properly. So we also, you heard talk about the shared responsibility model. We also maintain our own ISO and SOC certifications as well. And then failovers, the on-command workflow automation. This has been great in terms of allowing us to reduce the amount of effort required to do the testing and maintenance for the DR solution. As a side note, we also use workflow automation to automate how we resize and rebalance customers as we move them into the AWS environment. It just allows us to be more efficient when we do that. All right, so reducing risk while migrating critical data, obviously, one slide too many. There's a slight delay. All right, so again, we talked about we have data protection for using snapshot copies, replication, use deduplication as well. Moving with Cloud Volumes ONTAP allowed us to, take all those petabytes of data and do it safely and efficiently. And having deduplication in place has led us in particular, and mileage may vary accordingly, but we've had a 20 to 60% space savings across various workloads in the environment. So that has, resulted in a less expensive overall solution to manage in this space. So very good results. So next you see my quote where I'm managing to get the word availability in 3 times in 2 sentences. So it is critical, right? And we talk a lot about why it's so critical for our students is that in a lot of cases, we work with schools that have kids who are not doing as well in a traditional bricks and mortar school, for example. And so when the product's not responsive, they will disengage very quickly. And so we want to make sure that we are always there, always performant for them when they're ready to get engaged. So aside from all the obvious reasons, there's so many things we need to be able to do for those students that it's just absolutely critical that we're there for them. So the results, we reduced the risk. We've had huge success in terms of how we've been able to move and do it transparently for our customers so that they aren't seeing the risk. They're not worried about it. The data is available when needed. We protect it and it's performant. And as well, we are seeing the benefits of freeing up time for all members of our teams, whether they're more on the operations side or on the development side, to be able to innovate. And our product roadmap is starting to see the benefits of that, and our customers are starting to see the benefit of that. And we're scaling the organization in a way that as our revenue and our customer base grows, we're not having to introduce the headcount in that same linear manner. So it's been phenomenally successful for us. So Stan, who's on the call with me, is my head of AWS enablement. So he's been, the one doing all the heavy lifting and all the hard work to make sure that our teams, our products, our solutions are ready, and that he's really the mastermind behind how efficient our DR solution has become in AWS. So by the numbers, we're much more responsive in terms of how we can react and scale and prepare for anything that comes and be proactive about it. Our availability, we have SLAs with all our customers. We are by far exceeding those, so there's been no real issues around availability. Durability, the data itself is intact. It is, we've ensured that it's exactly what it needed to be and what it was in the colos. And then content, again, it's one thing to be available. Our students and our customers need to be able to access that content as well when necessary. So we've made sure that that is a responsive element of the solution. And again, I talked a little bit about, reducing the storage space 20 to 60% for specific workloads. That's been hugely beneficial as well. So the accountants enjoy seeing the price go down for some of those things. So looking ahead for us, we still have some work to do. We are still in our colo data centers, but the majority of our customers are now in AWS running on ONTAP. So we need to close that off. And then again, as I talked about, we are really starting to see some of the benefits, and it's starting to pick up momentum in terms of our innovation, our roadmap, and the capabilities of our staff. I'm watching that closely. I'm expecting that to continue to grow and accelerate throughout 2019 and 2020. So very exciting time. It's been a great partnership with AWS and NetApp. Looking forward to continuing that and driving the right type of successes for our company, for our customers and the students that rely on us. So with that, I think I'm done and it's time for Q&A.
All right, thank you very much, Mike, for that great presentation on what DTL is doing with AWS and NetApp. So now, as we mentioned, we're going to transition into our live Q&A. Just as a reminder, you'll be able to submit any of your written questions through the question panel. And in the event we're not able to answer everyone's questions today, we're going to follow up with everyone individually via email. So that being said, why don't we get started? So I see one question right off the bat that we have is, will we have access to the recordings and slides after the webinar? Yes, the slides will be available by SlideShare, as well as the recording of the webinar, and that will be available about 2 to 3 days. So keep an eye out on your email for that. The next question that we have is for I think for Jens from NetApp, and the question is, how does NetApp deduplication differ from AWS EBS snapshot delta change, or does it utilize that?
All right, that's an excellent question. So the snapshots that we run and our deduplication is all done at NetApp's waffle file layer. So it's not at the AWS layer. So when we create our aggregates, we actually go and take multiple disks, put them together, and then we write our file system across those disks. And then we go and write our blocks in 4K chunks. And our deduplication will go and look at those 4K blocks and say, if the signature of block A and block D are the same, let's have our inode table point to block A for block A and D, and then remove block D out of the equation. So that makes it highly efficient for that. As for the second part of that, utilizing the snapshots, our snapshots are, again, at the inode level. When we do a snapshot, we lock the inode table for the active file system. And that's near instantaneous because it just locks that inode table, creates a new inode table, and then the new inode table becomes a portion of the active file system, which includes those blocks that are locked, so that when we go and write a new block, it just goes and adds to the block levels that are there. And it's, again, at the 4K block chunk. So it's very, very, very different than it is from using the AWS resources of putting it into an S3, where when you're doing the copy into the S3, it's going to be a full data set dump into that, and then it's going to be at a large footprint capabilities. As mentioned, that your dedupe rates are going to vary depending on your workload. Traditionally, we see anywhere between 20 and 90% depending on the workload. So it really can drop your footprint costs. A good average that I see is 40-ish percent. But again, the mileage will vary on what you get from a deduplication perspective.
Thanks, Jens. The next question is for I would say for Mike and Stan at the at D2L, and the question is if you've ever had to exercise your DR plan, or perhaps even you could talk about if you've ever had to do a DR test and any information you could provide about lessons learned.
Yeah, it's Mike. It's a great question. So thankfully, we've never had to do it in a disaster scenario. So, but we do test regularly. So we had done tests in our colo environments, and that's where we realized we were coming up hard against some of the RTO commitments we had. So we were making it, but it was getting to be a little too close for comfort, especially as we scaled out. So that was really another impetus for us getting this into the AWS environment. We've exercised it within AWS now in various scenarios, and the lessons learned. Again, first few times you do something like this, make sure you take the time to document, put the timings down so that you've got them, and you can understand where things maybe you did before and how they're going to change differently in the AWS world. It's going to be faster, but at the same time, you're going to have to modify some of the processes, even if it's not technology related. It could be communication related and things like that. So how you engage the business differently. All these things are considerations when you are going to do it. Take it from your current environment into the AWS world. I don't know if Stan's got anything to add, but that should be good then.
Okay, thank you, Mike. Next question is for you, Jens. So the question is, is it possible to replicate data between an on-premise NetApp filer and Cloud Volumes ONTAP, and vice versa?
That's an excellent question. So as we go and think about that, the ONTAP operating system in Cloud Volumes ONTAP is the exact same operating system that you will have with your on-premises NetApp. So the same snap mirror that you would use to replicate between two on-prem systems is the same snap mirror that you would use to go and send that data out to the cloud. The differential between the two is that when using Cloud Manager, to replicate your data from on-prem to the cloud is a simple drag and drop operation, walk through a wizard, hit go. Process that if you were doing this manually takes 5 to 10 minutes. Doing it with Cloud Manager takes you roughly 30 seconds to go and initiate the transfer. The transfer will obviously take time depending on the amount of bandwidth that you have and the amount of data that you're trying to push, but absolutely you can go and get the data up to the cloud. Then in the event of a DR, you just break the relationship temporarily, just don't delete it. It will run out in the cloud, and when that DR event is complete, you do a reverse sync, which then pushes the data back down to your on-prem, reverse that again, and then you're up and running back on-prem.
Thank you, Jens. So the next question is for Mike and Stan again, and the question is, did you perform a POC as part of the D2L's process?
Yeah, we did. It was, we came in, we had, we probably ran our POC for, I want to say 6 months or so, and we started out in a smaller markets first. We do have a global presence, but we wanted to try it out in some places where in the test environments where we weren't going to be too heavily utilized to start, and we were primarily focused on let's try to reduce costs, let's try to improve our DR, and let's make sure that we don't sacrifice anything around performance, security, and the typical things you would look at, right? So, and we've been successful in solving really for all of those, right? There's still a lot of opportunity, especially around the cost area, where we're getting better and better at how we manage and operate in AWS, and each year, actually each quarter over quarter, our teams are continuing to drive those improvements down. So it's very much a living and breathing thing, but we've been very happy with the results so far. So.
Great. Thanks for that, Mike. Uh, so the next question is for Jens, and this question is about utilizing RAID with the cloud volumes on tap. And the question is, what kind of RAID groups are used to create the aggregate, and does it support RAID DP, or is that going to be available in the near future?
So RAID DP is actually not in play for Cloud Volumes ONTAP. We rely on the AWS reliability of the EBS disks. If you actually look at the AWS documentation, they do not recommend running RAID DP or any other RAID on top of theirs other than RAID 0. So we run a RAID 0 on top of the EBS disks. We do a maximum of 6 disks into a RAID group for that. But when you go and combine with the S3 aggregate portion of it for your capacity tier, you can actually go and get quite a bit of capacity on that. Because as I said, in the majority of environments, after 30 days, 70% of data never gets accessed again. So that kind of gives you an understanding of that portion of it. So it's a RAID DP is something that we've been looking at, but again, we don't want to go and introduce things that is going to put it out of compliance with the AWS environment as well.
Yeah, and I think just to add to that, as Williams, as he mentioned, we don't generally recommend using RAID for several reasons, but that's one of the reasons we recommend using the multi-AZ deployment, as Jens pointed out before, because you have protection, across, separate set of disk and different availability zones that are synchronously replicated. So on that, we're right at time, so we're going to go ahead and close. Please remember to fill out your satisfaction surveys after the webinar. We're always interested in hearing customer feedback. And thanks everyone for attending today, and thank you to our presenters from NetApp and from D2L.
Thank you.